All right, good morning. We'll go ahead and get started. By way of introduction, my name is Sean Bice. I work in the Database Systems Group. Joining me today will be 4 other colleagues. So when we put this session together today, we sort of had a couple of choices. One was we could show you a whole bunch of slides, or we could skip that and actually build a modern app using our data services right here in front of you. So we're going to go that route. We've got this nice little timing list down here, so we're going to try to cover a lot of ground. And then at the very end, if we have time, we'll all be up here to take questions. So when you think about, as a developer, and especially the keynote this morning, I think we all recognize that data really is or can be used as a currency if you embrace it. And there's this argument that basically says, as a developer, if you're embracing data into your applications, that you're going to, you really are going to enable a data-centric culture. And then if you sort of carry that a little further, it basically says businesses that embrace data with these types of applications will be more competitive than businesses that don't. And that's just how important data can be in applications. Now, when you think about this whole notion of building a data-centric culture, I just kind of use this as a frame. It really argues that companies that embrace data basically means the more people that can get ask questions and get answers, the more competitive they'll be. To have a data-centric culture, you need a consistent data lifecycle. I don't know that it really works with one without the other. And then this wheel sort of represents what we think as represents what is a consistent data lifecycle. It's just these 3 parts that you see around the wheel. It talks about collect and manage. You could be collecting data in all sorts of formats, and then once you've collected this data, how do you transform and analyze it? And then the 3rd part really talks about how do you visualize and decide on what you're seeing. So this whole concept of a data-centric culture, if you're going to build an app that's taking advantage of data, the one way to think about it is sort of what you see over the page here is an expansion of those 3 parts. We have been hard at work expanding our data portfolio. This is the most comprehensive data portfolio we have ever had at the company. And I feel like it's just the beginning of what's to come. So from a collect and manage standpoint, if we were here 5-10 years ago, we would have been probably talking just about a relational model. Today, there are all sorts of systems to collect different types of data. It can be relational, it can be documents, it can be files, it's streaming, the list goes on. Then when you think in this whole transform and analyze, I think Joseph did a great job showing a bunch of machine learning and how you can use analytics to even produce more value out of the data you have. And then finally, across that top banner, it really shows you from dashboards to being able to type a question into a dashboard. I think in the keynote, somebody inked over Power BI, show me sales by map. That's just an example of how quickly somebody can visualize and decide against data. But I think shows you the opportunity you really have as developers to embrace it. Now, this whole notion of today is going to focus across this bottom tier. And really what we're going to do is take an application and we're going to modernize it using a set of Azure data services so that we can build a modern app. Now, I know we always hear this notion of a modern app, and frankly, sometimes folks are like, hey, what the heck does that even mean? That's what we're going to try to show you firsthand today. One way to think of a modern app is, take a scenario of IoT. You could have millions of cars emitting tons of telemetry. Where does that telemetry go? It's going to end up in the cloud. It's going to come through big, giant networks that can scale with that. Or an enterprise application. And that enterprise may span across a continent, across the world. And how does that app literally go from something that's local here in San Francisco to spanning the world instantly? That really puts a lot of pressure on this app tier. I think you've seen a bunch of good demonstrations so far of this notion of a very scalable app tier. But when you get down to the data tier, this is where there's been some fundamental change in the industry. Arguably, the biggest change in the industry for data is happening right now. What do I mean by that? Think of a modern, or think of an application like, has anybody here purchased a concert ticket online, just by raising hands? Almost all of us. So take an app like that. When you swipe that credit card is going to result in a transaction. That transaction's probably running against a relational system. Pretty straightforward. SaaS world, much more complicated. Why? Well, as you have no idea which concerts are going to be popular. You may not know which ones folks won't have interest in. You're not really sure how to provision it. And this is where the scale numbers, you keep adding events and events and events. You're constantly having to guess, do I over-provision an environment or do I under-provision it, just at a database level. Then you think of things like when let's say you're trying to purchase a ticket, and right before you go to the purchase, you know how we usually look at a seat map and you're like, hey, I would love to know ratings. Before I buy a ticket in this section, I'd like to know what previous people have thought about these seats in this section, and is it worth it? Wouldn't that be fantastic? Or you think of things like search. If you're collecting data in multiple stores, how do you search across all of those stores in a really intelligent, all these data stores, so that you can get back intelligent results and you can get customers to where they need to be in a smarter and faster way? And then finally, think of how a ticket seller could run analytics against all those weblogs that result and show you every transaction that's been made. You know, how do you get some predictive analytics in the system so that if people are really excited about a particular data, as Joseph was talking, data in motion, if people start tweeting for a concert, wouldn't it be fantastic if you could sort of intercept this data in motion and maybe even help it influence search results in real time? So that's what we want to show you today, is how you can do that as a developer. So the first thing that we'll do is have Tracy come up, and Tracy will sort of switch into our role here. But first thing I love to do is take a look at our concert application, and we know we're trying to host as many concerts as we can. I know there are struggles with, we don't know which ones are going to be popular versus not popular. There's a constant guessing game, but just show us how we can use SQL database to help us do that first part of the problem.
Okay. So the application we have is Wingtip Tickets, which is the ticket app Sean was referring to. And one of the things that we're showing here is this Carey Ferry concerts. We're going to do a whole series with them, and working with the coordinator of this, they've got to go through, and I'll show you the screen on this, they've got to actually come through here and say, hey, where do I want to have the concert? So let's say we wanted to use San Francisco. Let's pick here, Moscone Center. Let's pick the event, which is this Journey to the Moon by Carey Ferry. And one of the things you'll notice here on the very bottom is this thing, expected ticket sales rates, small, medium, or large. And as Sean mentioned, you're asking the person who's coordinating the event to figure out what their rate of demand is, which is a very hard thing. For us as the SaaS provider of the app, it's lining that with a database that has a various performance level that we're going to tie to it. So in this case, it's small. Now I'm the guy responsible on the back end for making sure this thing's going to work. And so one of the things I have is a load generator that I run against this database. And that's meant to trigger off a certain amount of load so I can see what capacity we have with it. If I come in here, and what I've done in this case, small means a basic database in SQL DB. And so when we come through this, you'll start to see the load that'll be generated. And this will take just a second to come through. But in here, it shows the attributes right here. You can see it's a basic database. It's our inexpensive one with a certain level of performance. But this load is running here on the bottom, and it's showing me I can sell about 180, 190 of these tickets per second, which is reasonable if it's not going to be a super successful concert. But if this is a big one.
But if it's a big concert, and this is where problem number one, if it's a big concert, the last thing we want is users ready to purchase, and we're just watching this doom scenario of a slow experience. I need to purchase it right now.
That's right. And it used to be when we were first starting, we only had 5 or 10 of these venue customers. They could just call me, and I could update this basic database to a higher level database. But if you imagine when we're successful and we got thousands of customers, there's no way you can do that manually on the back end.
Database per database.
That's right. So the world I'm trying to get out of is this managing this part. So that's why I want to go to this new environment of the elastic pool environment, which we announced yesterday. And that's the concept of having a pool of resources that I can put many databases in, and they can be elastic, meaning each one of those databases can use the resources they need when they need it. So if I just walk you through the simple configuration, we've got a pool set up here. It has 200 DTUs. It shows the space associated with it. And how we've always set this up is the top part is the pool, the bottom part is the database information that you put into it. So if we were just to show you, for example, to configure this, you would define the pool size, and in this case, in our preview, we have set selections. Later on, we'll have more variability, but it's 200 now. I can set it to 400, 800, what have you. And then if you go down on the bottom, to be consistent with our database selections, I can pick what the max is per database as far as their DTUs or the min. So I can coordinate the resources that I want to give to all the databases that I put in here. So in this case, we've kind of, I've moved in that database already, that basic database, into here. In fact, I'll run the load generator against this database now that it's in the pool, and you can watch the bottom to see the difference in the performance, and we'll see if it passes the first one as we go through that. And while we're doing that, I'll bring up all the databases that you can see in the system that are in the pool. And there's 29 of them in the pool. They get ordered by load on the system, so you can easily check and monitor it. And then we'll bring up the customer one database here, which will show the load that's taking place with it. Now, if you notice the very bottom, you can see that I'm getting around 1,100 tickets per second versus the 180 that I was getting on the other side.
So the example here could be for each venue or concert could result in a database, so I get some sort of isolation. We don't know, in this case, when you run that second load generator, instead of it being a standalone database that's basic, that's the under provision that could result in a bad customer experience, slow transaction. You're putting them in a pool, then these databases are sharing the resource. So for example, if everybody gets excited for this concert and goes to buy, that database is is using compute resources from the pool.
That's right.
Got it.
Exactly. And if you do a comparison, this showed the first database that I showed, you can see it's pegged at 100% utilization up here. So we were getting the max we could possibly get out of it. If you go to the right, if we gave this a few more seconds, you'd see the little bump that's going to come up here, and we're using about 11 or 12% of the pool, and it's a much, much faster database. Now, the great part about all of this, if you remember back to the portal when we're asking the customer to choose which one they had to pick, now that whole option disappears because it's all dynamic. It's handled for them. It's handled for me. I don't have to think about it. And I've got a very consistent budget that I pay for this pool of databases, and each of them rises to the resources they need when they need it.
Yeah, that's awesome. Yeah. Thank you. Okay, so that first view is really intended to show you the power of these elastic pools. You know, oftentimes if you're building an app, you may decide that, hey, what I'd really like to do is have a database per tenant. It gives me nice isolation. But what you saw in that elastic pool announcement yesterday is this recognition as a SaaS developer, the last thing you want to do is manage databases one at a time. It's just not practical. We have real customers on our system. I'll give you two interesting data points. We have one customer's SaaS provider. They'll create up to 36,000 databases in one day, in a single day. Then we have other customers that will start with 10 hours of usage and in less than 6 months have over 50,000 hours of usage. So it really brings a lot of attention and focus that if you want to scale as a SaaS developer, these elastic pools are great. If you think of SQL database as a SaaS developer, my recommendation to you is sort of center on this concept of an elastic pool. It's pretty straightforward. Another great benefit is now imagine you have 10,000 databases in a pool and it's time to make a schema change or update some reference data. The last thing you want to do is spend time writing a bunch of complex code and retry logic to deal with that. In the demo yesterday, elastic pools, you can run an elastic job. You just take your script, you can paste it into the elastic pool job pane in the portal. You basically hit run, and then Azure will take it from there. It's pretty awesome in the sense of you know, how much time it can save you and the efficiency it comes with it. The only other thing that I'll point out here is these databases go from basic, standard to premium. And one important thing to call out is every service tier comes with a 4.9 SLA. So it's pretty awesome in the sense that in the time that I've been in this industry, we've really, our lowest end database is about $5 a month. And it comes out to something like 16 cents a day. That database has a 4.9 SLA. So it's, it's a little cheaper than a gumball when you think about it. Okay, so now let's switch gears and let's go back to the app. And then Ryan's going to join me here. So Ryan, here's the deal. So if we go to, let's see here. If I go back to home, which I can do here, here's what our customers have been asking for. So when we are selling tickets, like for example, if I sort of go down here and I go to find seats, one of the things that we need to do quickly, and I mean quickly as in right now, when somebody's coming in to buy seats, the feedback that we're getting is folks would love to see ratings here.
Okay.
So if, it could be a family that's looking for a certain section and not just the classic, this section is near the beer garden or away from the beer garden.
The one I always pick, yeah.
The one that you would pick. But what do people want to know, hey, somebody that I'm about to buy a section here, what do people really think about any time they've sat in that concert? So how can we get ratings added into this app right now?
And because I kind of, this is not the first time you've asked me to make these changes, and your requirements change quite often, and I guess you're going to ask different venues, want different fields, and all of that kind of stuff. We've chosen to use Azure Document Database because of its schema-free nature, so that I can quickly make changes like this to an application without having to go and write back and change data tiers and schemas and ROI
So the
maps
point
and all
is,
that kind of
with Tracy, a relational model for a transaction,
awesome,
great.
yeah.
But this one is, look, what we don't need to do is sort of go back through an entire modeling exercise just to capture ratings.
No.
That's what I love about DocDB. So how can we get it in here?
Great. So all I'm going to do, because I'm a developer, so I'm going to stay away from the database side of things. I'm going to kind of jump into some code. So let me open up Visual Studio. And inside Visual Studio, what I'm going to do with this application is I'm just going to go to the app, and I'm going to start off in a model. And right here on the model, I'm going to add a new model. So let's just call this ratings. Okay, and I'm just going to drop a new class in here. And I'm going to call the class rating. Just like that. And I am going to take that class, and I am going to insert a snippet that I've prepared before, which has my rating. Now, this is just a normal .NET class. I haven't done anything to it. I haven't created attributes on it. I haven't extended from a base object. Just a normal .NET class, which I'm going to kind of do. So once I got that, the next thing I'm going to do is I'm going to jump into the V part of MVC and create a view. So right over here, I'm just going to go add an existing view that I've built before. So if I go here, and there's the view that I've built, and this view is just a simple, CSHTML file with some Razor syntax in it. And right now, it's just got two sections. So it's got one for some comments, and it's got one where you can actually rate the section that you're sitting in. And that's, for now, that's good enough for the view. And then I'm just going to go into the controller, and let's go and add some stuff for the controller. So over here, I'm going to go and add in two new snippets. I'm going to add in rate my seats, and I'm also going to add in a snippet for submit the review. Right. So the first snippet I added in is the one that renders the view. The second snippet I added in is the one that actually goes and submits that rating to DocumentDB. Let's just do this. Point it at my model. And now you can see it's actually just taking that model, the view model, converting it into the model that I had, and it's calling into my repository. So this app uses a repository pattern, and we've got different repositories for different things. So in here, I'm going to go into my repo, and I'm going to stick in another quick snippet that says create async. And all that does is it literally says, hey, DocumentDB client, which I've instantiated in the closed up region, here's an object, and go persist it in the database for me. So let's just fix up that stuff quickly. And that's all I need to do code-wise to actually be able to capture ratings from my users, right?
Yeah, so we're not going into a T-SQL editor.
No.
You and I are not debating over schemas, and
at all, no.
we don't have to deal with that at all. So I'm assuming now we can easily plug this into the app.
Yeah, absolutely. So once we've got these, what I'm going to do, one last thing, is I want to extend that. So on that find seats thing, you can actually see these ratings that people are now starting to collect, right?
Perfect.
So I'm going to jump across to the portal quickly. So right here in the portal, I'm going to go into my DocumentDB account. And from the Document Explorer over here, I'm just going to go add in a JSON document that I have pre-done with some aggregations on it. So we actually have some data.
Let me ask you a quick question here, just for those of us that are new with DocDB. Should I think of a document like a table?
Some people make analogies of documents to records inside of a table.
I see.
So the document is the thing that we're storing. So you think of a document as in your entity that you're actually storing. So a row in a table.
A row in the table. Yeah. Got it.
Except in a document database, those rows in those tables can be different.
That's
so every
the beauty
document
of it.
could look different, absolutely. So here's that JSON file, and all you'll see inside of it is it's got some recent reviews by section, and each section is kind of rolled up into some aggregates, and then we roll up all those aggregates into the venue itself, right? Now, to use that data inside my application, come back in here, I'm going to go through the same process that I went through earlier. So in models, I'm just going to go add in a new model. Okay, and I'm going to call this one venue rating. All right, and just replace that with a snippet again. All right, so here I've actually got two classes. Again, just normal .NET classes. Done nothing special to those. Then go down to the view. This time I'm not going to add a view. I'm just going to go and edit an existing view that we have because that's what you asked me to do. So I'm going to come down to the view, and there it is there. And what I'm actually going to do over here is I'm going to insert a snippet. Now, let me actually just go and find that quickly because my writing JavaScript is I'm still getting to writing JavaScript comfortably. So let me just go down. Here's a div. So let's just take that div and stick it in there. And then I'm going to come down to the JavaScript part of this file down here, and I'm going to take that JavaScript function. And all this JavaScript function is it does a simple AJAX call to a controller, right? So there it is there. When the document's ready, let me call this new method. Okay, and in the combo box, when I change the value, so when I pick a different section, let me call that method as well. So that's what we need to do to the view. Jump again into the controller. Okay, and in the controller, just add in some code over here, which says controller get ratings. Okay, and again, that one just calls into the repo. So last place I need to change some code is inside the repo. I'm just going to kind of go and say insert snippet and repo, get venues, get ratings by venue. And this time, you can see over here, I'm using SQL syntax because I'm still familiar with writing T-SQL kind of syntax. I could actually do this in .NET, in pure link if I wanted to. It's up to you entirely what you want to do. So that there then just goes off, executes a query. Now, one thing I want to make a change on, just this simple little code over here, is this time when I insert a review, what I actually want to do to this repo is this. So I've made a simple change now that says, every time you persist an entity, actually kick off a trigger that goes and updates that aggregate document, right?
Got it.
And that's it. That is all the code I need to kind of change. Now, if I run this application, it doesn't build. Thank you. Extra prize for that man who spotted that one.
Do you notice you got the feedback after you tried to run? Not before?
They were waiting for me to hit the go button to see if I put it in there just to see if you guys were paying attention. So let's wait for that to kind of fire up and get going. But while I'm done that, you saw it was really, really easy to do. It was just a few simple lines of code that we've changed. And now if I come along to this venue and I go find that venue, find seats.
There it
There
goes.
we go. All right. Now I have this cool little seat map that's in here, and there you can see some of those reviews that have come back from that aggregate document, right?
I see.
Now, if I I want to go buy tickets in the expensive section because that's kind of how I roll. But there's the aggregates, and you can see how that changed. If I now come along here, let's just go and log in and go to this, and let me go and buy some tickets. So I want to buy some tickets. It's going to go off. This is using Tracy's elastic pool. Probably not, because this is a local instance. So eventually. Well, let's not use that. I've bought some tickets before, so let's go into my events. And this is where you can actually now, once you're being at the event, while you're sitting there or on your way home or after the event or whatever, you can just go in and go to that rate my events, right?
Right, and then anytime, so the nice thing here is in about less than 10 minutes, we quickly added the ability using DocDB to get ratings.
Yep.
Now we can change this on the fly in a pretty straightforward way.
Yeah, I mean, if you wanted another field in there or you wanted a field specific to a venue, again, it's just some logic inside of my application that I would just go in and change that logic in the app. I wouldn't have to go back and change the data that's in the database.
That's right.
I wouldn't have to go and change a model. I wouldn't have to go and do some object relational mapping or anything like that. It's just change your models, change your views, and change the logic to persist that.
Awesome.
And that's all that's done.
Cool. All right.
Cool. Thank you very much.
Thank you. Okay, so if we come back to here, thank you, Ryan. So many times when we have discussions with developers, they'll first look at Elastic Pool and they'll go, great, I'm in the SaaS world. I want to take all the guesswork out of over and under provisioning. The next thing that will typically happen is you start looking at, this is a real scenario with, we introduced DocDB as a new way to enable a specific part of a scenario, which was capture ratings. If you think about it, when you hear about things like schemaless or schema-free, it really is about this iterative development process using DocDB for this particular scenario. And you can kind of start to see how these things are composing into what you might call a modern app. I think the real beauty of what you saw there is if we had more time and we've got more things to do, Ryan and I could sit here and just decide, hey, for this particular venue, let's add these 3 fields. Or for this other venue, let's go add 1 field. And we don't have to go model out do this giant exercise. We can go document to document, quickly start capturing data, and off you go. And because this is built on the core Azure platform, in terms of scale, this thing was designed to scale almost infinitely from day one. So with that, let's go back to the application. And now I want to think about intelligent search. So if Pablo will join me here, go back to this mini port. So Pablo.
Hey, how's it going?
Here's the deal, my friend. If
All
we
right.
go back to the app.
You do the buttons.
The buttons have been pushed. You focus on search.
Okay.
Okay. Hang in there, man. Okay, so here's the thing. We've got data in all these different repositories.
Yeah.
But the thing is where you get complaints like it's taking folks too long. Customers, it takes way too long to find a concert, and they're kind of navigating all over the site. And believe it or not, we don't have search. So how do we get search, not just search, but a smart search that actually can search across all these data stores built into this site?
Okay, so we want to add search.
Let's do it.
All right, let's do it. So what I'm going to do is, so we want to have a search box. Like, where is a website that doesn't have a search box? The natural flow we want customers to do is come to a website, type in what they're looking for, the event or the artist or things like that, and then find results quickly. So I'm going to do three things. I'm going to create a search index. Then I'm going to populate the index with data, and then I'm going to wire up search into the application. And I'm going to use Azure Search to do this. So first step, we're going to get Azure Search wired up into the application. So the way I'm going to do that is I'm going to use the Azure Search NuGet package. I already put it in the application. So during initialization, what I want to do is, if my search setup is not there, then I want to create it on demand. And if it's there, then I'll just start. So the way I want to go about that is I'm going to create a new entry point here. Let's call it search index client. And so this is a class that comes with the SDK and represents the entry point into the search client. So what I want to do now is, during configuration, I want to wire that up. And in your actual app, you may use an Azure like dependency injection mechanism to create this and have it globally available. So what I'll do now is, let me go back here. And let me bring in a little bit of code, and I'll walk you through it. So this code will achieve two of the goals we had. So what I want to do is, when I start, I want to create a search service client. I get the endpoint and the keys from config. And then I'm going to create an index, set up an indexer, and then run the thing for the first time. When I create an index, what I do is I'm going to check if an index called concerts already exists. And if not, I'll create it. When it comes to search, what we need to know about the index are things like what of these fields are interesting for actual searching versus which things you want to use for maybe faceting or filtering, what things you want to use for display, and so on. So this is all the information that we are collecting here in the index definition. I'm also setting up a suggester, and I'll get back to it later. Just remember that it's there. So the second step is create an indexer. So how do you get data into the index? There's two ways. One is there is a push API. So if your data is in a custom place, maybe it's on premise, or maybe it's in a custom store, or maybe it's being produced on the fly, then you can just call the push API and get data into the search index. The other option is if your data is in stores that we support, like DocumentDB or Azure SQLDB, you can just point us at the store, and we'll take care of all the mechanics for you. So in this case, I'm using one of those. I'm defining the data source. In this case, my data is in a SQL view, at least this slice of the index. So I have a Azure SQL indexer. I could also point this at DocumentDB, setting up a DocumentDB indexer. And then once I have this wired up, I can create an indexer and give it a source, a target, and a policy. Like in this case, the policy is do this every 5 minutes. Do it from this data source. And you can see here that what I'm using is I have a view that is already denormalized, and it has all the data I want to search on. And then I'm going to give it a name. So now I have an index and an indexer that they're going to be checked and created if needed during application startup. Then finally, what I'll do is I'll run the indexer on startup, so we have the data there, and then it'll continue to run on a schedule. In this case, one extra thing I'm going to do is reset the indexer, because I ran it before, to make sure we start from scratch. And finally, I'm going to wire up my client here. OK, so at this point, we have created an index, and we had created an indexer that in the background will continuously maintain my index fresh as data changes. What we need to do now is wire up search into the application. Let's do that. So first, let's create a search box. So not there. Let's collapse this a little bit. So I want my search box everywhere, so I'm going to do it in the layout file. And here, I'm going to go in and put a very simple form that just has a search box and a search button. So this guy, remember, is called search. And what I'll do also is I'll repopulate it with the same search value, so when you search stuff, it's still there. It's nothing too fancy. And this is going to post back to the server. So on the server side, I want to receive the search request and then execute it and render the results. So that's going to go into the home controller. So let's go there. And so what I want to do here is, if I land here and there is no search, then I want to run the code I have today. But if there was a search, then I want to execute the search request. So let's do some of that. I'm going to say search equals request, whoops, search. And then we'll say if this thing is empty, then we'll do what we did before. And if not, we'll execute the actual search request. So we have that. So to execute a search request, what we'll do is we'll use search results there. And remember that we created our search client. It's ready to hit the index. We'll go to the documents collection, and we'll execute search. So the client side of search can take the results from a search query and give you a direct, kind of a generic untyped dictionary, or you can type it to a particular model type. So then you can have the rest of your experience be typed as well. So let's do the latter. So I'm going to go to models, and let me add a quick model class here. So I'm going to create a class. We'll call it concert search hit. So this represents a hit within a concert search. Let me bring the code for this type from here. So you have to watch me type all these. So if you look at this is a plain object. We'll just deserialize the content of the search results into this. And I have a little helper to turn my model type into my view type, so I don't mix the two layers. So now if I go back to the controller, now I can say concert search hit. And as parameters, I'm going to pass the search with search string as typed by the user. I can pass search parameters. In this case, I'll just pass the default. And this is an async method, so it takes a cancellation token. We're not going to get fancy with that. And I'm doing this very modern, so I have this, all these methods are async. So let me turn this controller into an async controller. So finally, now I have to create the results. And for that, what I'll do is I'll turn this into a view, and I'll convert the search result into my model types only. Like I want none of the thing that surrounds them. Let me give you an example of this. So for each hit, we give you the actual document, in this case, a typed version of it. But we also give you highlights if you requested hit highlighting, and we'll give you a score in case you want to look at the score and so on. In this case, I just want the document. And I'm going to convert this to the view type. And remember that I had this this helper function that will do the conversion for me. OK. So let's run this guy. And what's going to happen now is, first, since it's the first time we run it, we're going to go create an index. We're going to create an indexer and set it up so it pulls data from our existing data source. I could have multiple of them. In this case, I created one, but I could have maybe one pointing at SQL, one pointing at DocDB. Or sometimes what happens is I have some data that is the input to the index and some other data that is analytical information that augments the stuff, and I can consolidate all of that in the one index. So let's see if the promise is true, and we can actually search for stuff. I'm going to search for Boston, and I get Boston stuff, or I can search for Bellevue, which is close to home, and we'll get Bellevue stuff, okay, or maybe April.
Hold on. Nice trick. OK, so when I use search, what happens is when I'm using a really good search thing, I don't have to type. I can misspell. I sort of start typing, and it fills it in for me.
Oh, a really good search thing.
A really good search experience. So if you think about it, this little trick of Bellevue in one word, just imagine something more complicated. But why isn't this thing helping with completions?
Fine, completion. All right, so all of this bit is to justify that now we're going to do search suggestions. So the idea is, we all do this. You go to Bing, and you start typing, and the first thing you do is you pause for a second just to see what comes as suggestions, and very often that's kind of the right next step. So your customers are going to expect that. How do you wire that up into your custom application? So let's do that. Remember that before, when I created the index, I set up a suggester. When you set up a suggester, you tell us which fields are interesting sources for bits of suggestions. And then we'll take that and create a special index that then we can query at suggestion time as you're typing. So I'm going to add a backend piece and a front-end piece for this. The backend piece is this new controller method. I'm going to call it autocomplete events. And what it does is calls the same client that I used before, except this time, instead of calling search, it's calling suggest. And it's saying, this is what the user typed so far. This is the name of the suggester. In this case, I enabled fuzzy matching. So if people make mistakes while they're typing, we'll tolerate some of those mistakes. And again, no cancellation token.
But hold on, just help me understand how this works a little bit. I can call this API and then I get suggestions for free, or do I have to update some catalog constantly for suggestions, or how does that work?
So the only thing you need to do is when you created the index, you need to tell us which fields are interesting sources for suggestions. Once you told us this, then we'll maintain our own index of suggestions on the side, and you don't need to do anything else. So finally, I'm just returning this as a flat JSON array where I'm just returning the text. You can also get fancier here and pull more information from the documents that are the sources from the suggestions. Like, for example, you can pull a URL and then draw pictures next to the suggestions or things like that. So let's wire up the front end. For this, I'm not exactly a UI developer, so I'm going to go low end. So what I'll do is I'm going to use the pre-built search jQuery autocomplete control. It's actually really handy for this. And I'm going to point it to the controller I had. There is a lot of pre-built controls, UI constructs out there that will give you very nice autocomplete experiences. So this was autocomplete event. And so let's run this version that now has remember, we did a backend thing where all we did is we called the suggest method on the search API. And then on the front end, we picked a UI construct, in this case, the jQuery autocomplete controller, to wire up suggestions. Let's give it a minute. So now when I start typing, I get some suggestions. So if we say April, we'll get all the things with April. And we can make simple mistakes like we can skip an L or whatever, and we'll still find stuff.
Oh, that's awesome. So now if somebody just came in and as you typed April, any concerts that looked like that were showing up is right there for me. Yeah. That's pretty awesome.
Cool. Well, thanks.
Now, there's one more thing, though. Type in April like you just did. So you see, here's one of the real business problems that we have. As a SaaS provider of selling concerts, we provide the infrastructure, we provide the experience, we're trying to make it better. But the reality is, when somebody's coming into concert, what we've often heard is in certain venues, like San Francisco, we might sell a venue out really fast. Mm-hmm. But in reality, it would be great if we could get some type of analytics coming in that sort of could change the rating list, so that our biggest complaint is people search, they find the very first venue on the list, they go to buy a ticket, and there aren't good seats. Got it. But it'd be awesome if we could somehow change the list and redirect people to where there's maybe more seats available. They have a better chance of buying a great seat.
Understood. So this sounds like a ranking problem.
Yes.
So what you want to do is influence the relevance of the search results. What is defined as relevance in a way that connects with your application, with your business goals. In this case, what we want to say is concerts that are more relevant for a particular user are those concerts that are more likely to have better seats.
Yes.
And we're going to do this. The way we can do this here is, let's say we have a big data team. Here we have one of those. Yeah. So the big data guys can compute for us a popularity index. So let's say, for the sake of argument, we had a popularity index. So how would we wire up the search ranking system so it uses that to tune how relevance works?
Got it.
So let me start by creating a baseline here. I'm going to look for the artist. I'm going to say San Francisco. And we're going to get some results here. So let's say I want to tune the ranking of that. So what I'll do is I'm going to go to the portal. And I'm going to find the search service that we've been using for this. And once this loads, we'll see. So here's the index we created just now. And by the way, you can see here all the indexer executions have been happening and updating the index. And here is my index definition. You can manage, I did it in code. You can manage all of these from the UI as well. But what I want now is a scoring profile that will tune how scoring works. So I'm going to call this scoring profile popular. Give it a minute to get created. And now what I want to do here is I'm going to add, so scoring profiles, you can tune the weights of fields and things like that. But you can also define scoring functions that influence how we rank items. In this case, I'm going to do a magnitude-based scoring function. I have a popularity field, so I'm going to wire that in. I'm going to say we want to do linear. I want to do a less than 1 boost, meaning the closer it gets to the upper side of the range, the more we actually lower the value. I'm going to start at 0 and end at 200. So there is this popularity index. There is a number that we have to compute in some interesting way. And once we have it, by having this hooked up into the scoring functions, these combined with the text relevance will influence the ranking.
Got it.
So now that we have this in place, I'm actually going to set it as the default, so I don't even have to change the app. So I can separate my application code from my ranking model. As these values changed, then my relevance will change. The only thing we need now is someone that actually can do some big data magic.
Big data magic.
Yeah.
Okay. All right. Thank you.
Thanks.
Good. All right. So if we go back to these guys we're having fun with this. We really, as we're going from left to right across the bottom of the page, what we're trying to really demonstrate right now as a developer, if you embrace data, look what you can do in these apps and how fast we're moving. So what we really want to, so from a searching perspective, everyone here is searching all the time. I think what Pablo just showed is look how fast you can use Azure Search. Embedded into an application, it can search across DocDB, SQLDB, and other stores relatively easy. But let's sort of take search to the next level. So to do that, I'm going to ask Lance, our last demo presenter, to help us out. So Lance, basically, let's switch this. I'm going to go back to 8 here. You want me to switch it now, or wait a sec? So what we need to do is basically influence these search results. So most of our scenario is just one last time.
Yeah.
We'll sell out certain venues. We get a ton of complaints from people that, hey, I went to this venue to buy a ticket, and it seems like the only seats for sale are in the last row. Doesn't work. But then we have these other venues that are not as sold out. They just have a better chance of buying a seat. So how do we use this big data magic to influence those search results?
All right, so let's come up with some ways to influence the search results. So the first thing I'm going to do is go into Azure, and I'm going to go to HD Insight and create a new cluster. There are two things I can do here. I'm going to create a storm cluster. I'll say custom create, and I can type in wingtip or whatever I want to name it. I can choose the cluster type. I can also choose the operating system depending on how I want that deployed. I've already created one of these here, and you'll see I've got a wingtip query. We've been saying wingtip tickets all week long, and I finally am starting to be able to say it.
Yeah, there you go.
All right, so I've got wingtip tweets here, and I can go in and I can actually dynamically scale the number of nodes, the compute that I apply to that workload, depending on how busy the site is. Now that I have that cluster created, I can go into Visual Studio. And here, we've done a lot of work in VS to make it easy for people to use Hadoop and big data technologies in general from inside of VS. So this is the Visual Studio tools, the Visual Studio add-in that comes in with the SDK for Azure. And the first thing you'll notice is that HD Insight, I can see all the cluster types that I have. I've got wingtip query and wingtip tweets. We've actually added, here I've mapped the log files from wingtip into a schema that I've overlaid on top of that. And from here, it actually looks just like SQL. I can use Hive, and we have statement completion and IntelliSense, so I can actually write code here.
It does.
And have it work just like I'm going against a relational store. Now I want to look at, I want to bring in, you said you wanted dynamic, to be able to dynamically change that though, right?
Totally.
Yeah, so what I want to do is I'm going to show how I can bring in Storm and use Storm to bring in Twitter data to dynamically change the index.
Yeah, this is like Joseph was showing today. This is data in motion. Imagine a whole bunch of people, they could be tweeting and whatnot. If we can capture that and help us determine which sites are going to be more popular than others, that would be good to know right away in real time.
So what we've got here is I can choose, I've got a new project type. I've got Storm types. I can actually pick a Storm sample I can write in Java, or we've also made it so that Storm can run with C#, so I can type in, use C# in VS. We've also added some templates here specifically for Twitter, and so I'm going to use one of those and use the Twitter sample. I've got that going right here. When I create when you create a sample with Twitter, And with Storm, Storm has really two components to it that you use. One is a spout, and the other is a bolt. A spout is what you connect up to the Twitter feed or whatever your incoming event feed is. And then bolts are the actions that I perform on the stream of data as it comes through. So the first thing I want to do is go into my spout, and I'm going to, because I'm kind of cheap, I want to just get this up and working and try it out. I'm using the free Twitter feed, and so I'm going to register a track, which really tells Twitter, hey, give me all the tweets that actually have this keyword or this hashtag in them. So I'm going to register for carry1 to start out with. And I've also, something I've done beforehand is gone into just my Twitter settings and typed in the Twitter key that I have. I also have a SignalR website that I'm going to use. I want to display the tweets more as a developer debugging tool for me while I'm doing this. And then the last thing I have here is my Twitter sample bolt. So inside the bolt, I have the key method is execute tweet. Here I get a tweet as it comes in from the feed. I map that to an event ID, and then I'm doing just a simple algorithm. You could write far more complicated things and cache this to an HBase server or to blob storage or some other database if you wanted. For the sake of this case, I'm just going to keep it right here. And as soon as I get more than 10 tweets for that concert, I'm going to go ahead and I'm going to make a call to the change search index. What that does is it takes the search service that Pablo just created, and it sends, I think I passed a value of 100 to that, so he just added a popularity ranking, and so it'll increase the popularity score for that particular event and actually cause it to go down in the search list, so that way when I search, the items that have the best seats available will come up to the top.
That's exactly what we want to have happen.
Okay, so now I'm going to go ahead and deploy. I can actually deploy directly from Visual Studio to the cluster that I created. I've actually already deployed this one, so I'm going to go ahead and pull up. One other thing I can do is I can look at the Storm instances that I've deployed here. So I've got one running. And I'm going to switch over now to this other machine. Actually, you can leave that there, and we'll just plug in over here on Tracy's machine. Now, at this point, I know that everybody was probably really excited when you saw that we were featuring Carrie Ferry in today's website, right? Because you're all Carrie Ferry fans. Absolutely, right?
Yeah.
So what I want you to do here is I have that app. This is that Storm Twitter sample app up here running. But in order to influence the search index, I'm going to need everybody to actually start tweeting about Carrie. And I'd like you to think back to maybe your favorite, how excited you were when you booked your first tickets to one of Carrie's concerts, or how excited you are about the upcoming concert that you've booked. And what we're going to do is I'm going to come here first, and let's refresh. Let's see. Refresh the website here. Now we've got search. I'm going to type in Carrie, San Francisco, and let's go ahead and look for that. And so the results I get back are the Independent, the Moscone Center, and Town Hall. Okay. So you saw that I was searching for carry1. I see already some of you have started tweeting. So go ahead, and I need you to tweet at least 10 tweets of your favorite experience. Now, the keyword is carry1, so you've got to say carry1 or else I won't see it. All right, we've got quite a few here. You guys are great. Now, I'm looking for some, it's awesome. She is awesome and hot. She's lovely. She does rock.
Hold on. This is actually live.
Yeah.
This is.
I'm just reading my debug console here, Sean.
Yeah.
Okay, so let's drop back over to.
Yeah. Good idea gone bad. Yeah.
Let's drop back over. And so the Independent is at the top here, so I'm going to go ahead and just hit refresh. And you can see that now my search results, the Independent has moved down to the bottom, and Moscone Center has bubbled up.
Yeah, that's awesome. Cool. Thank you. Thanks a ton, man. That's awesome. Okay, so we'll take questions here in just a second. So let's, we'll be mindful of time. There's 6 minutes left. I think what we really are trying to show you is that as a developer, you can look at all this just massive amount of data, and it can be overwhelming in a heartbeat. kind of goes back to what we set up in the beginning. The argument is developers that are embracing data are probably going to build some of the most important apps, at least, I mean, for sure over the next 10 years. There's so much data, and if you're embracing it, these apps can really light up, as you've seen here. And imagine a SaaS provider embracing all sorts of data, and what we've done here in a very short amount of time, as compared to somebody that ignores data. That's what we really mean by this data-centric culture and embracing everything you can. And we're just using a series of different data stores and technologies across the board. The work in HD Insight has been remarkable. As Lance was showing there, if you're not a Hadoop expert, no problem. You can go into the portal, spin up a cluster in about 3 or 4 clicks. It's remarkable. And then the tooling that he's showing is another thing to call out, because if you're in your familiar Visual Studio, boy, oh boy, if I can connect to that Hadoop cluster and have a good experience that is familiar, off you go. So what you really saw sort of over the page is the first demo that we looked at was around SQL. The encouragement there is with elastic pools. It takes really a lot of this guesswork out of, do I over-provision a database? Do I under-provision it? The change management is remarkable. So I'd really encourage you to, if you haven't tried SQL database, in most customers that we've seen, they'll literally start from 1. They'll go to tens to hundreds to thousands just like that. The second demo we looked at was DocDB. So if you have not used DocDB, the thing that we really wanted to get across today is, look, you can, something like ratings, you don't want to go through some massive schema modeling experience. DocDB is one of the best systems out there for you. It's remarkable. You look how fast we just went. I mean, I wish we had more time. We could go on and on and on. The third demo we looked at was search. I think all of us that use search, I think what Pablo showed us is how fast you can wire up search, but more importantly, how intelligent it can be in terms of auto-completions and suggestions. The ability to search over multiple storage systems is remarkable. And then with Lance, you're really looking at somebody using advanced analytics to help influence. In this particular case, all we were trying to do is when new people were coming in to buy tickets, direct them to sites that have more seats available. And we're doing that by using sort of a popularity for a venue event. So all of that said, that's sort of how you can think about using a whole bunch of data services to build a more competitive and compelling app. As far as a call to action, everything that you saw today is available for you to use. So you can jump into the portal and get started straight away. The second thing is, the way we tried to design today was or this particular session was just to show you very quickly how you really can leverage all these different data technologies to build a more compelling app. And then there's additional sessions that if you want to go do a double click on search or DocDB or HD Insight, things related to our data lake. If you're going after IoT applications, we've got a lot of good sessions over the course of the week. So if Lance and Pablo and Tracy and Ryan, if you could join me up here real fast. Tracy, that would be now fast. Thank you. So I just wanted to thank these guys. These guys have worked incredibly hard. They've poured a bunch of hours into it to just basically show that demo to you end to end. So thank you, gents. And then we have 2 minutes, so we'll maybe take a question or two here in this 2 minutes, and then we'll hang out and try to answer more questions. So if you want to go to a mic, please go to a mic so that folks can hear you online, and then we'll go. Yep, it's on.
I got a question about search. Now, for search results, is there a way to return highlighting? Like, say, if you misspell Bellevue like you did, like you know that correct spelling of Bellevue gets highlighted as what made that hit occur?
You know what? Here, use this.
Well, actually, it's on now.
Okay, there you go.
Thanks. Yes, so there is a way you can actually just say highlighting on and give us markers. So, like, what string do you want us to use to mark up the hits? And then both in suggestions and in search, we can give you the hit, the score, and also if you enable that, we'll give you a list of highlights. And what we do is we take a snippet. For short things like the title we saw here, where you get the whole thing, For long documents, we'll give you snippet around the hit so you can show that in the UI with some context.
My question is around Hadoop. So it takes no time to set up the Hadoop server, but sometimes we use more storage or blob storage, more information. So the settings could take a little bit longer for a more complicated scenario. So we have a situation that it's complicated to set it up, but it's actually only being used one time every month. So having this to set up the server all the time, every month, it gets complicated. But if you have it on for 1 month, only for 1 day of computation, it's very expensive. Is there a way to pause the server or to do something around that?
Yeah, so we don't have a way to pause the server today. You can absolutely store your metadata outside of the server so that you can dynamically just create the cluster when you want. One thing that we typically recommend for if you're just spinning a job once a month or once a week or something is to use the Azure Data Factory, because it can automatically start up HD Insight clusters and spin them down for you, wrapped around your job. So you can actually just go in, put your job into that. It will take care of managing the cluster lifecycle for you.
That was perfect. So let's stop there. We're going to stick around. I'm going to let these guys turn the session off. We're at the 60-minute mark. We hit it out perfectly. But for those of you that have questions, just join us up here, and then we'll go ahead and answer them for you. Thank you.
Thanks.
Thank you.